Hi everyone. In this video, I am going to explain regarding the linear regression. It is a regression algorithm. So, suppose I am going to take a very simple linear regression problem that is based on the height and weight. Based on the height, we are calculating the weight. We are predicting the weight, suppose. So, just now in my previous video, I have explained regarding the rainfall. So, in that way, we have the data of height and weight. Height weight chart is there. Nearly some thousands of records are there. This is the height and weight. So, based on the height means, suppose 162 centimeters or 150 centimeters, some 60 kgs, it is 50 kgs, like that, it is there. Suppose. So, in that way, there are, suppose 100 records are there. So, in that, 80 records we can give as a training purpose. After that, testing purpose, we have kept 20% of records. So, here what we have done in linear regression, we know, everyone knows, this y equal to mx plus c gives what type of line? It is straight line. In that, m is, this is a y equal to mx plus c line. In this line, this is x is nothing but, this is x is height. Suppose this is the y. So based on the x, based on the height, we are calculating the y. So this is the exact line. For with the help of 80 records, we have drawn a line. This line is a straight line. So that is nothing but y equal to mx plus c. We can say that. So here c is your y percent. It is a m is slope here. Suppose after drawing a line with help of 80% of records, we send the data of 20% of records for same line, for same algorithm. So what happened? This is calculated based on the height. It is a predicted value is here, y hat. This is a y hat. Y hat means system predicted weights. These are the system predicted weights are different from this line. This line is going through this way, but y hats are nothing but system predicted weights are different. But our actual values are here, predicted values are here. So there is a difference. Whatever the difference is there, this line is different. So this line length we have to calculate. Okay. So everywhere y hat and y hat and y. So nothing but that is nothing but just now I have explained y hat we have to take this from the algorithm, and y minus y hat. It is a cost function, nothing but. So each and every column, each and every row, we will get some y hat minus y I. With the help of y hat minus y I, we can calculate the cost function. This is nothing but CF is 1 by 2n summation of I equal to 1 to n yi minus y hat whole square. This is a cost function. So suppose here 2 kgs difference. It is a weight. So that it is I am saying as a kgs. 2 kgs. Here suppose 3 kgs. Here 1 kg. Here 1.5 kg. Like that, different weights are there. Some difference is there. So with that, what happened exactly? Wherever we are given this in this data, for this height, the actual are suppose 50. Here 53. Like that, totally finally this 3 is the difference. Cost function became as a 3. So it is 3 kgs here and there. It is predicting, not exactly 3 kgs. Either high, sometimes low, sometimes high, sometimes 2 kgs. Like that, it is predicting. Suppose this is nothing but cost function we have taken as a 3. But what is our parameter tuning? What we have to do? This 3 need to be reduced up to minimum. Not completely, we cannot reduce it completely 0. This 0 mostly never happened. Because if it is, it became 0 means there is no difference. 100% accuracy is there. for our model. But 100% accuracy, most of the times it won't come. 99.5% of accuracy will be there. So we have to reduce this cost function to 0. Not exactly 0, it may not come to 0, but as much as possible to 0, we have to reduce these 3 things. So for that, what to do? What we can change? As it is a slope, this is a slope. With this slope, line is like this. If we change the slope, what will happen? Line can be drawn as a like this or like this. So in number of ways we can change the slope. As we change the slope, this line will change. Okay, this line angle will change. So that whenever this angle is changing, this line is changing here and there, this line slope is changing. This y minus y hat, these y hats will be changed. Y hats will be the y minus y hat values will be changed. So the cost function will be changed. So the cost function need to be reduced. If it is going too much high, more than 3 it is coming. So our change is different way. So we have to make the changes in positive side. Positive side or negative side, with the help of this thing, we can find. So if the cost function, as the cost function is here, so we have to make the changes in our slope value, m value. So when the slope value, what slope value, the cost function will come very minimum. That is our model. That slope value need to be fixed there. With that help, we have to build our model. That is final model. So that will give with minimum error. With the help of height, it will predict the weight with minimum error. Not exactly, but with minimum error it will give. So what to do for that? For which m, what is the cost function? So for that, this gradient descent curve will help us. So for suppose this is the m slope 0 and 0.5, here 1, 1.5, 2, 2.5, 3, 3.5, like that. In different m values are there. Suppose we have taken slope as a 0.5. With help of slope, with help of 0.5 slope, if I have calculate, cost function km is 3, suppose. So cost function is 0.5, 1, 1.5, 2, 2.5, 3, suppose 3 is there. So for 0.5, it is a 3. So this is a 1 point. After that, what happened? We have to make change. 3 need to be reduced. So what to do? Again with 1, with slope value, with m value 1, we have to calculate once again this cost function. Again we have to draw a line. After drawing a line, what will happen? Y minus y predicted values will be changing. So y minus y hat values will be changing, so that the cost function value will be changing. So what happened now? Suppose if we change the slope from 0.5 to 1, suppose it changed to 2.5. 2.5 as a cost function came. So what happened? This 1 to 2.5, it came here. After that, if I have changed to 1.5 as a slope, again it is reduced to it is a 2.5. Suppose it is 2. Like that it is coming. So for different m values, different cost function values are coming, so that this curve will come to some point. After that, what will happen? If we change more, here what is 1, 1.5, 2, 2.5, suppose 2.5. After 2.5, what is happening? Again it is going bad. Means here again y hat minus y value is more. So the cost function is becoming more. So if the cost function is becoming more, means what to do? This is not the correct way, but some point. So this is not the correct. This is also not correct, but this is the correct point. 2.5 is our, suppose 2.5. At the m value 2.5, our cost function is very less value it is giving. So here we are fixing our model as a m value, slope is at 2.5. So how it became? How to derive this? With the different m values I said just now. But different m value means m value how to take? For that also we have a formula. That is nothing but how to take. We have taken m value as a 3 here. The next slope what to take? We have to m minus dou by dou m of dou by dou m into alpha. What is alpha? Alpha is a learning rate. We have to call as a learning rate. M is slope, dou by dou m. It is a learning rate. So partial differentiation with respect to cost function we have to do. This slope need to be taken as a, this is a slope m, this is a cost function, dou by dou m means it is a cost function. We have to take cost function is in y axis. So this m need to be taken as partial derivative of m with respect to cost function. This called as dou by dou m into learning rate. This learning rate is nothing but 0.001 we have to take. So that what will happen? This is the new m. Suppose if it is taken as a m1, this is the m1, this is the m2. M2 is nothing but m1 minus dou by dou m1 into learning rate. This learning rate is 0.001 I am saying. Why we have to take this 0.001? Why we need not to take the 0.1? You may have the question. Because this learning rate need to be very small. So that what will happen? Very lot many points will come here and here and it will come like this. Because if we have taken very high value as a learning rate, what will happen? After coming here, without coming here, after coming to this point, without coming here, directly it will go to here. So this is called as a global minima. We cannot reach to the global minima of m value, slope value. Because a very good example I want to say. If we want to take 1 kg of rice, if we go to shopkeeper, what he will do? Randomly he will pour some rice into that balance. After that, what will do? It may some less or high, 1.2 kgs like that it may come, or 800 grams it may come. But if 800 grams it came, then what he will do? He will pour some more rice. Okay, but not very high, heavy rice he won't give. Because if we pour more rice, what will happen? Immediately it will go to 800 grams to 1.2, 1 kg 200 grams or 1 kg 100 grams. But if it came to 1.1 kg and 1 kg rice, what will do? Immediately he has to remove some of the rice from there. If he removes again some more rice, what will happen? Again it will come to 900 grams. But it will never come here to here, here to here, it will come roaming. But it never come to 1 kg of rice. In the same way as global minima, it cannot be reached. So that we have to pour very less number, less rice, like that we used to pour. So that after some time it will exactly 1 kg, it will balance. So it has to be 0.001. It's a learning rate we have to take. It is most of the times we used to take as an alpha value as a learning rate. As 0.001. You may ask, why don't we take more small? 0.0001. We can take, but what will happen? We can pour the rice, some of the rice to, we have to add some of the rice to the balance, but not going to one seed of rice, no one will add. If we add one seed of rice to that also, from 800 grams to 1 kg comes, for sure it will come. But by evening it will come. It won't come even within 5 to 10 minutes. It may take 1 day or 2 days also it may take. So here also same manner. So we have to take small value as a learning rate, but it need not to be too small. If it is too small means nothing but to balance 1 kg rice, we have adding one seed of rice again, 1 seed of rice every time. But no one will use it to do that 1 seed of rice. In the same way, we have to take learning rate as a 0.00 or 0.001 as a alpha value. So that what happened? Another m value came. So for different m values, for each and every different m value, different cost function values are coming. Again for next time, again the same. With respect to cost function, we have to take the partial derivation of the slope and multiply it with the learning rate, so that another m value will come. With that again m value, another cost function will come, so that this will come. So this global minima, wherever it comes, whatever the slope value here, this slope value need to be taken for our model. They will have to fix with that model. This is all about the linear regression model. Of course, it is very simple because here only one parameter we have taken, height, and height. Based on height, we are making weight. This is a linear regression model. I think you understood exactly. As for understanding purpose, I have taken very simple problem. So I think I explained as much as possible as you understood. Thank you. Please come.